Let me share the screen. Okay, thanks for the consent. So we can start. I hope everybody can see my screen. Nitis, can you confirm if you can see my screen?
Yes, Jackie, we can.
Okay. So guys, welcome to the first meetup of 2020 overall 32nd Surat MuleSoft meetup. In today's meetup, we will going to discuss about a CQRS pattern. It will not take more time. It will take 30 to 40 minutes with demonstration. So like CQRS stand for command and query responsibilities segregation. So we will going to discuss about this particular pattern, and this particular pattern is mostly used in a microservices world basically, and we will going to deep dive into that particular topic. Okay. So a safe harbor statement. So I will start with the first safe harbor statement. So both speaker and host are organizing this meetup in individual capacity only, and we are not representing our organization or our companies here basically. And the presentation is strictly for the learning purpose only. Organizer, presenter do not hold any responsibility that same solution will work for your business requirement also. The presentation is not meant for any promotional activities. Okay, some housekeeping. So recording of this meetup will be uploaded to event page within 24 hours. So like it doesn't take 24 hours, it will get uploaded in 2 3 hours basically. You can ask question at any time. You can open your mic, even you can make use of chat window if you have any question. So just make a session more interactive. Apart from that, like we doesn't get lot of feedback, I request everyone to provide the feedback. This will help us to select the right topic and to do the future improvements. Okay. So organizer myself Jitendra Vapna, and I will ask Nitish to introduce yourself, like
Thank you, Jackie. Everyone, welcome to first meetup of 2022. I'm Nitish Jain. I'm working in Accenture, and I have more than 3 years of experience in MuleSoft. I'm certified MuleSoft developer architect. That's all from my side.
right, we are working with Excel, so let me correct it.
Sure.
Okay,
Thank you.
thanks Nitish. So I will introduce myself. The speaker for today's meetup is myself only. So I have 14 plus years of experience in integration and APIs. Currently, I'm working as a, senior solution architect 3 at a EPM Systems. And I am a MuleSoft certified integration and platform architect. I am also a cloud certified architect. Apart from that, I am also TOGAP 9.2 certified. And I like one of like my main expertise in setting up cloud hub like customer hosted mule runtime with anypoint VPC DLB, and even like I have experience in setting up runtime fabric manager, and also like expertise in implementing API using MuleSoft API led connectivity and event driven architecture, and expertise in digital transformation, right? So agendas for today's meetup, like we will discuss what is CQRS. So CQRS stand for Command and Query Responsibility Segregation. Apart from that, we will see what are the advantage and the disadvantage of CQRS pattern. What are the use cases where you can use the CQRS pattern? Apart from, we will also see like where you should not use a CQRS pattern. Then we will see how we can implement this CQRS pattern with MuleSoft API-led connectivity architecture. Finally, there will be a trivia quiz. Let's start with a CQRS. So CQRS basically stand for Command Query and Responsibility Segregation. Command and Query Responsibility Segregation pattern. We separate a read and operation to data stores. So basically, what does this mean? So basically, like you will have a separate database. You will have a separate data store for read operation. You will have a separate data store for the write operation. So you will have a two model. There is a one write model. The second is read model. So basically, you will have a two databases. So with from one database, you will just do all the read operation. In other database, you will come like you will just do the write operation. But like there will be the replication done from write database to the read database, but it can produce a eventual consistency. We're going to discuss more about that, what is eventual consistency. So basically just keep one thing in mind, like pattern separates a read and the write operation to data store. So basically you will be have a two separate databases. You will have a like SQL server 1, you will have a SQL server 2. In one SQL server you will do all the write operation, in another SQL server you will do all the read operation. And from write SQL server there will be the replication happen to the read SQL server basically. And there can be a eventual consistency. So I will going to talk about what is eventual consistency. So implementing CQRS pattern can enhance the performance, scalability, and security. So basically, like you can scale any SQL database. Like you have a separate database for read, you have a separate database for write. So you can independently scale any database, like any database basically. If you want to scale, if you see the load on read operation is increased, so you can scale that particular database independently of a write SQL database basically. How? Like, so command should be task based rather than data centric. So basically it should be a task based. Like if you want to perform some series of operation, series of tasks basically, yes, you have to use this CQRS integration pattern. Just if you are going and just like inserting a simple data, in that case it is not recommended to use the CQRS pattern. So the commands may be placed on the queue for asynchronous processing rather than being a process asynchronously. So command is basically used for modify operation, so for modifying the data, whereas query can be used for retrieving the data or fetching the data. So basically whenever you are performing any write operation, so basically whenever like you are getting the request from any consumer, you can place that particular message into the event queue, into queue basically. And from queue you can process the message and just write to the database. So this can be asynchronous, whereas whenever you want to read the data, that operation can be a synchronous operation basically. So query never modifies the data. Basically there are two things, commands and query. So query never modify the data. Only command can modify, update, write, or delete the data basically. So for greater isolation, the data stores are physically separate for the read data from the write data. So I mentioned, so like there will be two SQL server. They are physically isolated. Like they are physically isolated basically. So basically one SQL server is only used for write operation, the other server will be always used for the read operation. SQL server is just an example. It can be any data store basically. It can be MySQL, it can be MS SQL, it can be Oracle database, it can be any other data store. And there will be the replication from write database towards the read database, and it can have an eventual consistency. So when I say eventual consistency, it means, so like you have written the data to the right database, so it may take some time to replicate data to the read database. So that is known as a eventual consistency. So eventually eventually the data will definitely replicate to your read database, right? So this is known as the eventual consistency. So data sync between write and read data is done using master slave replication on MySQL. This is MySQL is just example. However, the same can be achieved using any ETL tool, or even you can use a mule batch program as well, right? So basically you can use the internal facility provided by a SQL server for replicating the data, or otherwise you can define any ETL process, or you can make use of mule batch program as well. Okay, so this is about a SQL integration pattern. Sorry, CQRS integration pattern. CQRS integration pattern means like you have a separate operation for separate data store for read and separate data store for write. So it means you will be have a separate API for read and separate API for write. So we will, and generally it is recommended in this CQRS pattern, whenever you are performing any kind of write operation, it can be asynchronous. Whereas whenever you are performing any read operation or any data fetching operation, it can be a synchronous operation. Any question? Yeah, Suresh, you can definitely make use of that, right? So but you have to ensure that there is some kind of replication happen from one NoSQL database to other NoSQL database. So I mentioned you can use any kind of data store, but you have to ensure that there is a proper data replication happening between these two write and read data store. So Let me go to next slide. So as I mentioned, so command modifies the data which can be insert, update or delete action, whereas query it never modifies the data, it only perform a select action. Okay, so that is the difference between command and query basically. Just keep in mind CQRS stand for command and query responsibility segregation. So command only modify the data, whereas query never modifies the data, it can only perform the get operation, whereas post put operation can be performed by a command basically. Okay, this is how a CQRS integration pattern looks. So basically you have a command, this is the write API, query this is the read API basically. So somebody want to perform want to insert or modify the data, it will call a command, right? Command will write or modify the data in the right databases, right? And whereas like whenever UI or any consumer want to read the data, it will call that query operation, and from query it will call a read database. There will be the replication between write database and read database, so that can leads to eventual consistency. I have discussed what is eventual consistency. There might be possibility a read database maybe sometime is stale, right? Maybe by 2 minutes or 1 minute, by 30 seconds. So basically whenever you write the data, so replication may take like some time, like maybe 30 second, 10 second, depending on what kind of logic you have defined in your process, so this is the this is how a CQRS integration patterns looks like basically, right? Any question? Let me check. So see, Ashok, I already mentioned, right? So there can be eventual consistency. The eventually data will get replicated to read database. So like database not be it not be 100% synchronized at same time when you are performing the write database. When you doing any write operation, it may take some kind of like time, right, to get replicated in read database. So I will come to on that. Correct, Boris. Yeah. So let me go to next slide. Okay, so there are some scenarios where you can make use of this CQRS integration pattern basically. The scenario where performance of the read operation must be fine-tuned independently from the performance of the write operation, especially the number of reads are is more than writes. So I will come to on that. So basically like let consider if your read operation have a have a complex query which contains 6, 7, 8, 9, 10 joins basically, right? So that query can take some time like to get executed, right? And even the number of reads are much more than write operation, right? So in that case you can make use of this particular pattern basically. So whenever your query is very complex and like whenever your number of read operation is much more than write operation, and where like you can scale your read database independently or read model independently without impacting a write model basically. In that case you can make use of this CQRS integration pattern. When you have a complex business rule and SQL queries are complex, in that case you can make use of CQRS integration pattern. Like other thing, like if you want to parallelize the development and use the two team, one team could be assigned to read model and second one to the write model basically, right? So if you want to enable the parallel development, so one team can one team can develop all the API related to read model, and one team can like start developing all API related to write model. So in case like if you have only few endpoints, in that case I am not recommending this particular CQRS approach. But if you have a number of operations are much more for read as well as for write, in that case you can go with the CQRS pattern when the performance is critical. So basically whenever you have required the high performance, so your query should execute very fast basically, right? In that case you can make use of this CQRS pattern basically. So large project where performance is required and independent scalability is required. So in case like your number of write operation is much more than read operation, right? So you are getting a lot of orders basically, and you are keep on adding those orders into a database. In that case so basically suddenly after 2 or 3 months your number of write operation like got double or triple of like what was before 2 months or 3. In that case you may have to like scale that particular write model, right? So that can be that can be scale up independently without impacting a read model basically, right? So that is where you can make use of a CQRS integration pattern. So CQRS integration pattern, when not to use. So whenever like there might be possibility like somebody, some of the organization, some of the enterprise, they cannot accept a eventual consistency. As I mentioned, like sometime whenever we write the data to write database, so eventually it'll replicate to the read database, but there might be possibility it may take 30 seconds, it may take 40 seconds, it may take 30 minutes also. It depends on what kind of process you have defined, like how frequently you are replicating the data. It's completely depend on that. It can be real time also. It can be like sometime you can have some like kind of batch processing, some kind of scheduled job. So it depend on that, right? So that you can expect some kind of eventual consistency. So like the organization who cannot accept this eventual consistency, I will not recommend it to use the CQRS integration pattern. So like for simple crude operation, like for simple read write or write operation, you should not use this particular CQRS integration pattern. If you like, if your queries are complex, number of read and write operation are like much more, right? No, in that case you can go with a CQRS pattern. When you have a simple business logic, right? Just let me finish this. When you have a simple business logic, then implementation of CQRS would be too overwhelming basically. Yeah, any question?
Yeah, there is one question, Jackie, from Fahim.
Hmm.
So,
No, fine. Like you will have a two API. So one is for read, and other is for like one is for read. So like whenever you will search the product, right, it will go to the read database. So that API will call the read database. So once you have searched the product, right, then later you will place the order. So while placing the order, it will call the write database. So the order will be placed using the command operation, whereas searching product will be like placed using the query operation. Okay, so these are the two different operations basically. Okay, so let me go to next slide. Okay, so what are the advantage we are getting with the CQRS integration pattern basically? So the first, independent scaling. So if you see, in case if your number of reads are much more than write operation, right, so you can like scale a read model independently of a write model to get the better performance basically. And it's vice versa. In case if your number of write operation is getting increased, right, right model or right operation is increasing, in that case you can just scale up a right model basically, right? So you can like allocate more resources. Either you can do horizontal scaling or either you can do vertical scaling, depend. In case like your number of read and write operation both are increasing, so you can scale up both the systems basically, or both the write and read model basically. A single responsibility principle. So there are a separate model, read and write. It means method should be either command or query. With this separation, you get a simple responsibility principle by design. So simple, right? So like one API will take care of the write operation, one API will take care of the read operation. So like one API will call the write data, like it will send a command to write database, and one API will send a command, a query to the read database, right? So in this case, like there's just like single, like one API just do the write operation, one API just do the read operation. So it's a single responsibility principle, right? So it's by default, like it's a single responsibility principle basically, a separation of functions basically. Since there is a separate model for read and write data, you can keep a complex business logic validation for write model and keep your read model simple to fetch the data. So there might be possibility when you are inserting the data, right, you may have to do a lot of validation, you may have to do a lot of checks, right, whether these particular fields are there, or maybe there might be possibility like whenever you are doing some insert, so like to do the insert you may have to search some other data, right? So like you have to do some orchestration of the calls or all those things, right? So that, and apart from that, you may have you may have to perform some kind of business logic, right? So like that might be possibility for the write operation, but for read operation you just have to simply fetch the data. There is a no business logic, right? So in that case, like you can define all your business logic, all your validation in the write model, whereas like you can keep your read model simpler basically. to fetch the data. So that is the separation of concerns. Any question? So I will come on that, Aditya. So I have a good example with the API-led connectivity. So I will going to show a complete demo with all the APIs, with API-led connectivity architecture, where like we will going to use like queue mechanism and all those things, So basically, as I mentioned, for write operation, it is recommended to have a asynchronous operation. For read operation, it is recommended to have a synchronous operation. We're going to discuss that. So don't worries about that. So we're going to see with some example. Okay, so what are the disadvantages? Definitely each and every integration patterns come with some of the disadvantages, right? So definitely there are pros and cons for each and every techniques basically. So as there is a different read and write model, so duplication of code is unavoidable. So basically whatever like create tables, like whatever store procedures, whatever like queries, whatever you have in a write database, it's the same thing will be in the read database basically, right? So duplication of code is unavoidable. Like you cannot like keep code at a one place and like the both the database can like can access those particular code basically. That is not possible. You have to keep the like whatever store procedure available in one database, that has to be available in the other database also. So that's store procedure, just example. There can be functions, there can be triggers, there can be many other things, right? So there is need two separate database for read and write model. So write database needs to replicate data in the read database, that may leads to eventual consistency. So I mentioned, right? So generally what happens, somebody is writing the data to the database. So somebody has updated or somebody has deleted that database, right, from the right database. So like replicate like write database will replicate those data to the read database, right? So it may use some internal like replication method, or it can be any batch processing, or it can be any mule batch process basically, right? But this will always leads to the eventual consistency. So I cannot tell what will be the exact time. It depend on what kind of scheduler you have defined. Sometimes it can be a real time also, right? Also you can write the triggers. So you can write the triggers on one server. So basically whenever any update happening in on one server basically, so you can create some link server, and from link server you can replicate to others. So there are various mechanism available, right? But you have to ensure that like whatever you are replicating, that is reliable, right? That is persistent. Like what like you need to ensure that that is 100% getting replicated in the read database, right? So that needs to be taken care. So like in case if if data is replicating from write database to read database, so that part needs to be designed by a DBA, a database administrator. In case if you are using mule batch processing, then you are the person who have to design it properly basically, right? Okay. It adds unnecessary complication if application of a simple CRUD operation, which can achieve by the traditional architectural style. So as I mentioned, like if you are like using this particular pattern, the CQRS pattern for the simple CRUD operation, where like you are just having the simple query and simple write operation, simple delete operation, right? So it is recommended not to use this particular approach. Like apart from that, why I'm saying that, because maintaining two database may require a separate licenses. Also like you have to have a backup database for both the database. So there are a lot of things, right? So like just make sure if you like if you don't need a heavy performance, like if you have a simple query, simple CRUD operation, don't go with this approach. Simply use the traditional approach, where you will have a single API which will take care of all the read and write operation, and you will have a single database which will take care of read and write model both. Before I go to API-led connectivity architecture, any question? So Prasan, like real-time use cases already I've discussed, right? So where we can use this particular I have seen this particular architecture mostly used in the microservices world basically. So microservices world, like at an enterprise level, where like I will give one simple example. I have seen this particular pattern for one of the organization, where if you see, this might be mostly used for e-commerce basically. In e-commerce basically, you keep on receiving lot of orders, right? And like let consider you have done some kind of order, and you will simply, once you have registered the order, place in the queue, right? From queue it can go to write database, and whenever you want to read anything, you can like read it from a read database. That can be one simple example. This is just an example, like, yeah, this is the CQRS pattern in API-led connectivity architecture. So I have a three system API. I have a order system API. I have a customer system API. I have a order detail system API, and I have a two database: write order database and read order database. So definitely there will be some replication between, like, replication setup from write database to read order database that may lead to eventual consistency, right? So just even I can merge this particular orders and custom API into one also. So that's not an issue. But just for showcase purpose, I'm doing this way. Then you have a order process API. So order process API is nothing. It's a process API where it's like doing the orchestration of call. It is calling the multiple API, like orders API and the customer API. So basically, it will do the right operation basically to orders, and like it will do the post operation to order and customer, and order and customer will be written to the right order database. Then finally, the experience API, here we don't require any kind of a process API, like, or like we will just pass the order number, and like it will call the order detail system API, and order detail system API will read the data from read order database basically, right? So that is a simple architecture, and like this order expense API will place the order to the queue basically, right? And this, like, there will be some listener which will pick the message from queue, right? And it will place the order, as well as it will add the customer detail to the customer table. So they both are available in the right order database, whereas we have a read order database. So where, like, we will going to fetch the data. The express API will directly call the system API. It will fetch the data, and it will send to the order express API. This is the simple architecture where we can make use of this CQRS pattern. So mostly, like, we have to handle this particular part at the system layer. Basically, you can see that, right? So any question on this architecture? No, like, I am not providing directly access to the user. Like, there is a possibility, like, you can definitely call a directly system API from the experience API. Like, I'm not providing directly access, right? So if you see my architecture, so we have a something called experience API. We have that experience API is accessing the system here, because I don't have any transformation or any business logic available, right? So yeah, it this is not rule, like you need to always, like, experience API needs to always call a system API. So there will possibility like experience API can directly call the system API also, but here I am not giving directly, like, user is not directly consuming my system API. It is consuming via my orders experience API basically. Yeah, Ikram, you are right, Ikram. So that's a good example. So you have took the real time COVID example basically. So that is a good example. Okay. So this is simple application. Let me walk through. So right now I don't have a two database. I will just perform like read and write operation in same database. So I have a three table. So one is like let me execute query. So it's nothing in there, like order header, which each order I can have a line items. Okay. So there is nothing. I have a customer order customer. So customer detail. Okay. So let me walk. These are the three table. So order header. So it will contain main order header. Then related line item is in the order lines, and related customer information in the customer table. Right. So these are the three tables I have in my database. Let me go to some of the APIs. So I have order system API. So simple API, like, So let that flow. Okay. So basically, like, I will be receiving the request using, like, this is my system API. I expose one HTTP endpoint basically. Okay. So that will like I will receive the request through, I think this is which order. This is the order sys API, right? And this is the push. So I will like process API will call this particular system API, and it will insert order into the database. So basically, like in the order header, then like it will retrieve the order ID. Okay, so like order header ID basically. So once it do the insert operation, so like it will retrieve the order ID, because order header ID is the auto increment field in my SQL database. Then finally, like it will JSONify this response, the convert into the JSON. Then finally, like it will also going to insert order lines basically into your database. So once like it first it will go to insert orders, like it will get the order ID, like then it will insert these order lines basically. And the typical the payload will look like this, let me show. This is my payload, like system API should receive this particular payload, like order, like with two line items basically. Okay, this is a simple payload. Now let me check the other API which fetch, let's see a customer detail. Okay, so second, like with order we can get a customer details also. So this is also simple API where we have a post customer operation, and this will again call by a process API basically. So we talk about order, now we are talking about the customer. This order and customer will call by the order process API. Okay, so here we will insert a customer into a database. So let me show the customer database. So we have this customer database. Okay, we will going to insert data in the customer, and finally we will retrieve the customer ID and we will just revert back, as simple as that. Okay, the third API is the order detail CC API. Okay, so this is my third API, order detail system API. So this is again a simple API. So I'm getting like get orders. So I will get the order number in as a query parameter, and I'm just selecting the customer and the order detail. Okay, as simple as that. And just I'm reading the order number from the query parameter. So this is my third system API. So generally, like I am using right same database. Generally for this particular thing, there should be a separate database and there should be the replication between write and the read database. Simple. Now I will go to the process API. Okay, the process API will receive the message from experience API via event handler, via queue. Or experience API will place the message to particular queue basically. Okay, so like to the queue I will show that. And like once it receive the message from queue, so it will do the it will add into orders, it will add into the customers. Okay, so like this is on new message. So as soon as I will receive the message to JMS queue, I will like this is a simple payload. Just I am like creating a customer payload. So here I am just reading a customer data. Okay, the like customer data. So one, then I'm calling the system API basically, right? The customer system API, right? And then finally I will create, once the customer has been successfully created, then I will like create let me show in diagram. So like already called the system API via HTTP request, right? Now secondly, like I'm just creating order payload, and I'm again calling the orders system API. So I'm calling this particular API, right, from the process. It will do the insert and finally it will log it. So like I cannot, I don't want to send any response back, right? It's a simple asynchronous processing. So that is my order process API. Let me show my last experience API. Okay, so this is simple. In experience API I have a two operation. So one is post, like where I will just place the message to the queue. Okay, and one is the fetch get operation where I am just consuming a system API and getting the data. So before that I want to show you one more thing, how the order API, the example. So this is how input will look to the process API. Like I will have a customer detail, I will have a order detail with all the line items basically. Okay, simple. Like this is the simple payload. Okay, so you can see there is some kind of logic available in your process API where like it doing the orchestration of call, then it doing the splitting of this particular payloads basically, right? So those kind of things is available. Now finally I will go to experience API, and this is the input to the experience API. So this is like message will be placed into any like into JMS queue, and this is how the experience API looks like. So basically I will be receiving message via HTTP listener, and I will publish this message to this particular JMS queue basically. Okay, so JMS queue, and like as I mentioned, like in process API we have a JMS listener which will pick the message and it will do the processing. And finally whenever you want to retrieve any kind of data, so like this particular I will like call this get orders basically, right? and with this get order, I will pass the order number, and it will finally call this system API directly basically to fetch the order details. Okay, so here you may use the request operation, right? So HTTP requester. Any question on this particular use case? Right? You understand the use case, right? Okay, no response. Yeah, okay. Okay, so good. So this is like what I have done. I have deployed all my API on runtime manager. So you can see it here. I already deployed. So I have all API, customer system API, order detail system API, CQRS system API, like process API, and finally I have experience API. So I have all my 5 API here basically. So the first thing I will going to execute this particular operation, right? Once I will send the message, that message will be placed into the queue, and we have a order process API. There's a JMS listener which will pick the message from queue, which will contain customer detail, order detail, and line items. So order process API first call the customer API. The customer data will be added to the customer database, customer table, and then finally it will send the orders and the line item to order API. The orders will be added to orders header table, and orders line item will be added to the order lines item. So this is what will going to happen. Okay, so this is my payload which contain customer detail, order details, and the line items. So let me push this send. So order has been accepted. Let me check with the back anything happen on the background. So let me check query. So I can see there is a one order added to my order database. There should be two line item. So I yeah, the perfectly two line item has been already added to this particular order line item data there, and there should be one customer detail. So I can see my one customer detail has been successfully added to my database. So let me do the second operation. So where I'm calling like API order a get operation. So I'm trying to execute this particular path basically now, right? So let me send the request. So I got the order details, like for this particular order number, I got this order, right? So generally, I cannot set up two MySQL server on my laptop right now. Don't have that much space, right? But like in future, like in real time, you need to have a two databases which will contain the same table in both the databases basically, and like you will do the write operation in one database and read operation from the other database. So we other advantage, can anybody tell me what is one more advantage we are getting related to security? Yes, so Hannah, right? What happened? So like uh, Experience API has exposed the HTTP endpoint. So like for creating the order and customer detail, right? So I send the message to the Experience API over the HTTP. Then Experience API publish the message to JMS queue basically. If you see my Experience API, right? Where is my Experience API? Yeah. Yeah, you can see this is my publish operation, right? So where it is publishing the message to the JMS queue. So as soon as I publish my message to JMS queue, right? So what will happen? Let me go to process API. So I have a JMS listener. So this on new message, right? So if you see there is JMS listener, this particular JMS listener, it's in process API basically. Pick the message, then it will like call two system API, customer system API and order system API basically. Okay. So that is how it's happening. Is this clear? No, consumer is calling the HTTP API, right? So consumer is calling the HTTP API basically, right? But in the backend, consumer will call the HTTP API. We get the message. As soon as we message, we just send the message back to customer saying we have accepted the message. In the backend, we send that message to queue basically. Okay. Can anybody tell me one of the advantage we are getting related to security? Aditya, you are it's a perfectly right answer. So basically, like you can have a separate right. Generally, what will happen, if you are doing if you are maintaining one database config, right? So for read and write, you will have a same user which can do read and write operation. You can do like you can create two config also with different user, but doesn't make sense, right? But in this particular CQRS operation, definitely you will have a separate user for write, you will have a separate user for read. So that makes sense, Aditya. So that is the great answer basically. Yeah. So here I'm adding some of the references. So basically we have a something in GitHub also. So like you have a detail like article on this particular two website. So you can go through that. So I already done the demonstration also. Any question and answer? Any question? Any? Yeah, Suresh, like in these cases, you need to have to configure something callback basically, right? Where you can notify the consumer, so like your API, something got failed while order processing. Other thing, I will tell you what happened. Like you let take the example. You are doing you went to Amazon and you have placed the order, and initially you see the order has been placed successfully. In that case, what happen, your order get placed in the queue basically. In the backend it does the processing, and sometime after few time minutes you can say your order has been failed, right? It happens, right? So what happened, like, I will provide one endpoint, right? So where like you can keep on, like your application keep on continue check the status of your order basically. Otherwise, so in that he will come to know whether your order is failed or with what reason. So you will have a separate endpoint. Otherwise, sometimes we can configure the callback also, where you can send the, like, callback is not a good solution. If you have 100 consumer, you cannot like configure the 100 of callbacks basically, right? So I will suggest like you go with basically this particular status, like you will have a order status API. So like you can like your any consumer like can check like after every 1 or 2 minutes what is the order status. Sometimes you can see in Amazon site also, initially it will say your order has been placed, after few minutes you can see your order has been filled, right? This can happen. I will share that, don't worry about that. So generally there is a status, order status link basically. Yes, you are right, Victor. So it work well with the event sourcing basically, right? Okay. So I can I think I have completed my session. So now I have a quiz time. So basically like we have a upcoming meetup like on 29th of Jan, which is like where like we're going to showcase how we can achieve the MuleSoft clustering in Dockers basically, right? So we will deploy like multiple Mule runtime in Docker, and we will cluster those Mule runtime, right? So Sudeshna Biswas will be the speaker for that, and this is the link for RSVP. So guys, like I will suggest like please provide the feedback for this meetup. And if anybody want like other thing, like if anybody want to become the speaker for this meetup, like upcoming meetups, they can reach me on Nitish basically. Like we are looking for some of speakers like who can talk on any technical topic or even like industry technology topic. Yeah. So this is all over the CQRS pattern. Like this is the short meetup, so it's already like late for people who are in India. So I kept it short. I hope like you understand like what is the CQRS pattern and when you need to implement this particular CQRS pattern, and what are the use cases, what are the drawbacks, what are the advantages, and how you can make use of CQRS pattern in your API-led connectivity architecture. Yeah, thank you. I will just stop sharing. I will ask Nitish to start with quiz.
Sure, Jackie. Thank you. And great session.
Yeah, thanks.
Okay. Let me share my screen. Okay. So, guys, we are going to start with quiz. We are using Kahoot for the quiz. So, we'll be requiring two screens. On one screen, you will be getting the question, the timer, and the options with colors. And on the second screen, you have to choose the option as per the color. Hope I'm clear. So I'm sharing the pen.
Don't worry, like if you have registered for this session, he will going to receive all the ppt videos, all the link which we have discussed in this particular session over the mail basically. So don't worry about that. So within 2 3 hours he will going to receive everything, so don't worry.
So I guess we were having 70 to 74 participants. So
Guys, one more minute, we will lock the game. Nitish is very strict about this.
yeah, we have to lock the game. Otherwise, while in middle, if someone joins, so no distractions, right, Jackie?
Yes, yes, true. I think we can lock the game now.
Sure, sure, Jackie. Okay, I'm locking the game. Okay,
Sorry
so
guys if
let's.
anybody missed it.
Yeah, now it's locked. Nothing can be
Just
done.
a minute, I need to give few instruction.
Sure,
Okay,
sure.
so guys, so basically so like once you win this particular game, right? So like we will select the top three winners, and like you will get the email with some link basically. So you have to fill up the form. So basically like make sure you select the training. I don't think like you will get a certification voucher, so you will get a training basically. This is mostly for like this voucher is mostly for the training purpose. Okay, other thing, like if anybody won the voucher in last within 1 month or last 30 days, right? So like I don't think he will get a second voucher in the 30 days even you win it. I don't know, like so like there can be some kind of check happen on the background. So generally like you fill the form that goes to MuleSoft, they, like there can be like some kind of check happening in the background. So just make sure if you have one voucher in last 1 month, so you can play the game, but don't win the game. But it's fine, like I don't have any problem. Even you want to play and you want to win, so you can try that, other thing, give the opportunity to all others to win the voucher, because if you have won any voucher in last 30 days, so let's other also like take some kind of MuleSoft training basically. And also like other thing, so guys, like generally once you fill the form, it take 5 to 6 weeks for like for the voucher basically. So you will receiving the mail like this is the schedule, and you have to just confirm whether you are fine with this particular schedule. You will get that mail for one time. If you rejected that for one time, you will not get that mail for time. Please make sure once you get that mail, right, so you just confirm that particular time basically. Otherwise you will miss that chance. Okay. So that is only instruction from my end. Nitish, you can continue with your game basically.
Sure, Jackie. And we can do one thing as well. Like from this meetup, we can also make a record of winners. What do you say, Jackie?
Yeah, sure, sure.
Oh, okay, sure. I'll do that. Okay, so let's start the game. Great. Okay, let's see the winners. Okay, Anjali, Aman, and Suraj. Guys, there are 6 questions, so you can cover up. Okay, Aman, Anjali, and Prabhakaran.
1.
Yeah, tricky question. Let's see. Oh shit. Uh, my bad.
That's fine.
Okay, okay. So,
Okay, can we go to next?
sure, sure. Great. We all were like attentive.
But still we are getting a lot of wrong answers.
Yeah. Okay. So, Suvarna, Sagnik, and Suraj. Last question. Yeah. You already gave an answer, Jackie, right?
Yeah.
Great.
So let's
Okay.
see the
Let's see the
podium.
podium. Sure. Great.
Sagnik, can you
Congratulations,
ping me your
Sagnik.
email ID? Suraj, can you ping your email ID?
Limelight. Suvarna. Congratulations, everyone. And Nitin and Kishore, maybe next time. You were close.
Yeah, I have took the photo.
Sure. So I'll unshare my screen.
So guys, anybody want to on? I will just stop the recording.
Yeah.
So anybody